It's Lemar. Today I'm going to be explaining the course practice quiz for physics, section 1.1 till 1.5. Okay, I'm only going to do the solving questions because, that's all we need to do for, solving, because the others are memorization. Okay, for part A, it's memorization. For part B, you have to do pressure law, which is P1 over T1 equals to P2 over T2. Okay, here P1 is 800. Okay, T1 is negative 73 plus 273 because we need to make it Kelvin. So it's 200. Okay, Kelvin. Now, the second pressure, which is P2, is 1200. So P1 800, T1 200, P2 1200, T2 is what we're trying to find. Okay, now P1 over T1 equals to 1200 over T2. Solve for T2, you will get you will not get 27. First thing, when you solve for it, you will get 300. Okay, T2 is equal to 300. Now, minus by 273 because they asked for Celsius. So minus 273, you will get 27. Always convert, even if here it's Celsius and here it's Celsius. Sometimes it will be a different answer, so always convert. Okay. This question. For part A, I and II, I'm not gonna do them because they're like common sense. Like in 0 Celsius it's melting ice, okay, and 100 Celsius it's boiling water. We should know this from before. Okay, now BI. Now all you're gonna do is look 22 centimeters. Now the distance between 20 and 30 is 10. Okay, and there's 1, 2, 3, 4, 5 boxes. So 10 divided by 5 is equal to 2. So each one is 2. This is 4. 6, 8. This is 4. Okay? They want to know at 22 centimeters. So we go 22 here at 60. So it's 60. Now, the size of 1 Celsius degree on the thermometer in millimeters. So, look at this. Here. 20, 20, 20, 20, 20. So 20 over 100 is equal to 0.2. 0.2 what? 0.2 centimeters, but we want to make it in millimeters, so you multiply by 10. By multiplying by 10, it will be 2 millimeters. Question 7. Here, because the pressure is constant, it's Boyle's law. Okay? We're gonna apply Boyle's law. The temperature is constant, it's Boyle's law. So, but here they're asking for the temperature of the gas in Kelvin. So 25 plus 273 equals to 298. Sorry about that. I don't know what's happened. as I was saying, you have to make it into Kelvin. So this plus 273, which is equal to 298. This is easy question. This shouldn't be wrong. 3 marks. Also this one, Boyle's law, we have to know that the temperature and the mass are constant in Boyle's law. Okay, the final volume. Now we have to find the final volume, which will be P1 V1 equals to P2 V2. Okay, P1 equals to 1, P2 equals to 3, volume 1 equal to 12, volume 2 equals to question mark. So 1 times 12 equals to 3 times V2. Find V2. V2 is equal to 4. Question 8, also Boyle's law. Here they're telling you Boyle's gas law. So basically temperature and pressure are remaining constant in Boyle's law. Okay. If the volume of the gas is okay, now they're telling you initial pressure. So this is P1. This is V1. This is P2. So P1 V1 equal to P2 V2. So 8 times 15 equals to P2, so 30 times V2. So 8 times 15 is equal to 120, which is equal to 30 times V2. V2 is equal to 4. Here, so here they told you that the here that we have to know that in Charles' law, pressure is constant. Okay, here what do you want to find? We want to find the volume. Okay, so here this is Charles' law. Pressure is constant. Okay, so we have to do this rule: V1 over T1 equal V2 over T2. V1 here is equal to 8. T1 is equal to 300 K because plus 273. The temperature is halved, so V2 is what we're trying to find, which is question mark. T2 is equal to 300 divided by 2 because it's half, so 150, and 8 over 300 equals to question mark, or let's say V2 or X or anything you want, over 150 times 8 divided by 300. V2 is equal to 4. Here also Charles' law. In Charles' law, pressure and mass are constant. Also here V1 over T1 equal V2 over T2. So V1 equal to 12, T1 equal to 300 because plus 273 to make it Kelvin. The volume 2 is equal to 18, T2 is equal to question mark, so 12 over 300 equal to 18 over T2. When we calculate it, we will get 450. T2 is equal to 450, but we want to make it in Celsius, so 450 minus 273, you will get 177. Pressure law here, pressure law is equal to, basically in pressure law, volume is constant, okay? So we have to apply the rule, which is P1 over T1 equal P2 over T2. This is 300K plus 273. This is volume 1. This is temperature 2. This is this is negative 23 plus 273, so 250K, which is basically T2. Okay, so now we apply it. This is P1, sorry. So 20 over 250 equal to P2 over 300. Then you find it, you will get 720. Let me just make sure about that. Yes, okay, yeah, that's correct. So yeah, the answer is 720. Wait, sorry, P1, yeah, I did something wrong, yeah. P1 is 600. This is the volume. Volume in pressure law is constant, so we don't count the volume. This is T1, which is equal to 250K. This is P1. This is 300K, which is T2. So now we apply P1 over T1 equals P2 over T2, and it will be 600 over 250 equals to P2 over 300, and then you cross multiply, you will get 720. Sorry about the mistake. Okay, now apply ideal gas law. So P1 V1 over T1 equal P2 V2 over T2. This is this is gonna be T2, which is also like it's 273 plus 147, which is equal to 273, yeah, plus 147, which is 420. This is T1, which is equal to 280. Okay, this is volume 1. This is pressure 1. Pressure 2 is double pressure 1, which is 5. Double يعني times 2, so this times 2 is equal, this times 2 is equal to the second pressure. So now we apply it. 20 times 2.5 over temperature 1, 280 equal to pressure 2, 5 V2 over 420. Then you cross multiply, you will get 15. Yeah, you will get 15. Okay, now new formula, which is average speed is equal to radical temperature, which is basically S2 over S1 equal to T2 over T1. Okay, speed 2 is question mark, so S2 over speed 1 is 1900 equal to radical T2, which is 1200 over 300, which is T1. You put it on your calculator, you do it in your head, whatever you want, you will get 3800. Okay, now question number 14. What you should know is that the average kinetic energy is directly proportional to the temperature. So if the temperature quadruples, then also the average kinetic energy quadruples. So if something is directly proportional to another thing, they will be if this is multiplied by 4, this will also multiply by 4. If this is multiplied by 2, this is also multiplied by 2 if it's directly proportional. Okay, now the average speed, we're gonna do the same thing as before. So S2 over S1 equals radical, it's the same thing, but here I'm gonna say average speed equals to 4t, which is this. Okay, we know that speed is calculated in velocity, so radical 4 is equal to 2, so speed is v, so 2v. Okay, now question number 15. Here we have to do this. First thing, you have to know that it's equal, Q equals M C delta T. Okay, here we don't have the Q. Okay, we're trying to find the temperature, so the Q here is gonna be, first thing, P equal to V times I. So velocity, volts times I don't know what, I forgot what it is. Anyways, 24. So P is equal to 24. Then another formula is Q equals to P times time. Time is 300 times 24. It will be 7200. So Q is equal to 7200. But we only found the Q. So now 7200 equals to M is 1 kilogram times the C, which is 380 times delta T, which we're trying to find. So solve for delta T, you will get 19. This question, easy. The boiling point, so the last point it reaches, it's here. So look here, 75. Between 70 and 80, it's 75. Okay, now Q equals MC delta T. First thing we have to find, we have the mass. We have to find Q here. So Q equals P times T. P here is 50 times the P is in watts, by the way, so times the time here, at the time where it was constant, at whatever you want to call it. Look, where here it meets, here it was right here, which is 340 to be exact, because we're not gonna do approximation. This is literally directly given to you. You're gonna look at it here. This is 310, this 310, 320, 330, 340. This is 340 to be exactly 340. So 340. This is 17000, I believe. Let me check. Yeah, 17000. The T here is final minus initial. The final, where we were at 75, it initially started at 10. So 75 minus 10, which is equal to 65. This is the delta T, 65. We're trying to find C, so times C, times, we have the mass, which is 0.1, which is equal to 17000 equal to 0.1 times C times 65. 65 times 0.1 is equal to 6.5 C, which is equal to 17000. 17000 divided by 6.5 is 2. When you put it on the calculator, you will get 2615 minus 384. They want you to make it like this in scientific notation. 1, 2, 3, so 2.6 times 10 to the power of 3. It's positive 3. In case you forgot, when we go backward, it's positive. When we go to the front, it's negative. Question number 17. We're gonna use Q equals ML. L here is 2400. The mass here is 50 gram, which is in kilogram is 0.05, because you divide by 1000 to get from gram to kilogram. So 0.05 times 2400, you'll get let me check, times 0.05 is equal to 120 kilojoules. It's in kilojoules because here this is kilojoules, but if this was joules, you have to, and here they said kilojoules, you have to do divide by 1000. You will see it in another question now. Okay, now this one you have to do 20 over 100. Basically this, because it's 20% is basically 20 over 100, so times 0.8, you will get 0.16, and then you do Q equals ML, 0.16 times 2.2. It's in this is in megajoules. From megajoules to joules, it's multiplied by 1 million. Okay, you will get 2.2 times 1 million. You will get 2 times 0, 220,000, or whatever, 22, then 5 zeros. This will be in millijoules, then times by 0.16, because we're doing L times M or M times L, whatever you want, is equal to 352,000. They want it in kilojoules, so you divide by 1000 and you will get 352. Okay, 21. You have to do Q equals to M C delta T. Okay, so this is C, this is C. Delta T is 80 minus 20, final minus initial. You will get 60. You have to convert this to kilogram, so you divide by 1,000, so 0.07. So 0.07 times C, which is 385, times 60, you will get 1617. They want it in kilojoules, so you divide by 1,000, you will get 1.6. Okay, now question number 23. They want you, they're asking you 23. Yeah, okay. Now you have to use this formula, Q equals ml. So here they already gave you the heat, the latent heat of vaporization. It's in kilojoules, so you have to make it to joules. So multiply by 1,000. It will be 300,000. Yeah, 300,000. It's already in kilograms, so 0.150 times 300,000, which is 45000 joules. To make it in kilojoules, you divide by 1,000, so it will be 45 kilojoules. Question 29, the last question. Just you have to convert Celsius to Kelvin, so 150 plus 273 or 273.15, doesn't really matter. So it will be 423. That's it.